Let's do this. So in this video, we're going to be looking at situations that involve functions, right? So instead of doing what we did in class where we looked at pictures of functions, now we're looking at situations that involve them. We're still going to use domain and range to describe our functions. We're not going to solve anything necessarily, but we are going to figure out sort of what the inputs and outputs could look like. Let's start with the first sentence. Alfredo is using a payment plan to pay for his new television. Stop. So he's buying a TV. He makes a down payment of $250. So $250 is the down payment. And we'll pay $75 each month until the television is paid off. So this is pretty normal, right? You go in with some money, the store lets you have the TV as long as you make your payments each month. If Alfredo makes payments for X months, so X is the number of months, then the total cost of his television can be represented by f of x equals 75x plus 250. So total cost is going to be that f of x, okay? So the total cost is the f of x, that's the output. And that output comes from how many months he makes payments, right? So x is the number of months. And normally if they give you a variable, you can kind of follow the word that's attached to it. And there you go, each month. So each month is the x. So they were really nice to you in this situation, or I was really nice to you. I gave you the function. So 75 times the number of months plus the 250 down payment is going to tell us total cost. And what you're going to do to kind of better understand the situation is you're going to use something that we used in middle school, or at least I did, called a process table. So we have x is the input, and what we're going to do is take that process, 75x plus 250, to make our output, right? So the output is just the f of x. So if you look, right, all I did was I moved the f of x equals to the end, but the rule is going to be the same. And what I'm going to do is I'm thinking about x, which is the number of months. So x could be 0 months, right? Because he's going to buy the TV, and at that point all he's paying is the 250. So if I plug in 0 for the x and I multiply it by 75, right, that's just going to give me 0. I add 250 to that, it just gives me 250. After 1 month he's going to owe money, right? So he's going to have to make his first $75 payment. So 75 times the 1 plus the 250 is going to tell us that after 1 month he's paid $325, okay? And Alfredo's going to keep doing this, right? He's going to go to 2 months. He's going to do 75 times 2 plus 250. And his total payments at that point will be 400, right? Total after 2 months. And you'll just notice the pattern keeps continuing, right? It's just adding 75. Well, if we're starting with 0 and he's only paying every month, right? This situation is going to be called a discrete situation or a discrete function, right? So in class that looked like a bunch of dots. Now it just looks like a bunch of whole numbers. Alfredo can't pay at the halfway point, right? So he's not going to pay after a half month. He's not going to pay after 1.5 months. He's only paying on the month. And for each month, there's going to be an output that comes from that. And so if we graphed it, it would just look like a bunch of dots. And so when we see dots, right, we just kind of focus on the points and how to describe them. So our domain is just going to look like a bunch of numbers that go in order, right? So the domain, remember, is our x. Starts with 0. Then we could say 1 month. We could say 2 months. And because we know how to count and we don't know at what point the television is going to be paid off, they don't tell us the total price, we're just going to put dot, dot, dot to show that the pattern continues. Man, that is not a good looking bracket. All right, so draw nicer brackets than me. Now the range, the y, or in this case, right, we could say the range is the f of x. So these are the same thing. We're just looking at the outputs. So when it's 0, the output is 250. So that's the lowest he could pay because that's his down payment. Then he's going to pay 325 after 1. After 2, he'll pay 400. And because we can see that the pattern is just adding 75, we're just going to go ahead and show dot, dot, dot to show that the pattern continues. Okay? If we knew where the television, like what the final cost would be, we could keep going, but in this case we don't. We're just going to show that we know the pattern and that it's discrete, so we're only showing each individual number. Okay? If we were to look down below, similar situation, we're talking about total cost in dollars to purchase Crockett High School Spirit shirts. So we can find that using the function C of S equals 9.50s plus 75. So that's our function, that's our relationship between the input S and the output C of S, where S is the number of shirts purchased, okay? So the only difference really so far is that instead of f of x, we're using a c of s. So the language is changing a little bit, but the idea is still the same. Here x is our input, here s is our input. So the more shirts we order, the more cost it's going to be. So let's keep reading. For the order to be made, at least 30 shirts will need to be purchased. So that's a little different. They're telling us that you have to order at least 30 shirts. And that's a pretty normal thing, right? If you're buying a product, I can think of H-E-B, for example, right? Like if you want to do that new service they have where you go call in your order and then they deliver your groceries for you, you have to have like a minimum purchase. You have to spend a certain amount of money. And so this shirt company is saying you have to buy at least 30 shirts for us to do business with you. However, there's a limit. So the maximum in this situation is no more than 120 shirts. Okay, so they're kind of setting like a minimum and a maximum. So we just need to figure out, does this go with the domain or the range? Let's use a process table to kind of think through this a little bit, right? So up here, our input was x. Here, our input is s, right? And you can see it, c of s. So that number inside the parentheses, or that variable inside the parentheses, is our input. So s. And then what's going to come out is the c of s, so just the cost, right? And to make the cost, we just use this process or rule. 9.5 s plus 75. And I just took that 0 off there. That's just a little extra. So in this case, what would you start with? Well, can you buy 0 shirts? In this case, no, right? The minimum number of shirts you can buy is 30. And then you could buy 31 shirts. You buy 32 shirts, right? You can keep going all the way up until ... 120. So in this situation, right, you can't buy, it's very similar, right? You can't buy a half of a shirt. So if you try to do that, they would probably hang up on you. They would think you're weird. They'd block your number, right? This is just a discrete situation because you can buy one shirt at a time. And for each shirt that you buy, there's going to be a set cost for that. So it's just 1 and 1, 1 and 1, right? So just again, it's a bunch of dots. So our domain, kind of like up here where we had 0, 1, 2, it's going to go 0, 1, 2 for our domain. Here we're going to have 30, 31, 32. The difference is we know what the limit is, right? So when we write our domain, we're going to write a 30, 31, 32, ... And then we're going to cap it at 120. So we'll actually show that maximum, okay? So that's just a little bit different. Now, if we wanted to find the range, we actually just have to plug in a few of these numbers. So I could do 9.5 s, instead of s, we'll put 30 plus 75, okay? I could do 9.5 times 31 plus 75. I could do 9.5 times 32 plus 75. And at that point, I've kind of established the pattern, so I'm just going to go ahead and find what is the maximum, right? So what's the most amount of money that I could pay? So at this point, right, it just becomes, can you plug things in a calculator, right? So if we see a rule that has multiply and then add, you always do the multiply first. So I'll do 9.5 times 30, get my answer, and then add 75 to it. So I'll start with a 360. And then what you'll see is like a pretty basic pattern where basically if I did 9.5 times 31 plus 75, right? All I'm doing each time is just adding another shirt. So 369.5. If I did 9.5 times 32 plus 75, I would add another 9.5, which would give me 378. All right, so I can just copy those down. 378, ... And then I am just going to show that maximum. So I'll do 9.5 times 120 So 9.5 times 120 shirts plus the $75 fee. And that's going to be 1,215. Okay, so that's kind of my maximum. So the only difference really between example 1 and example 2, so they're both discrete situations because we can only have whole inputs, right? The difference is here we know where we're going. So we know the end, so we'll just go ahead and figure that end out and we'll just add that on, okay? When you look at numero trace, that's number 3. This one's kind of like similar to what we just did. So I just want to see what you guys can figure out. If you can do this on your own, I would be so proud of you. Okay, that's enough. Goodbye.